Okay, 2003 Pontiac Vibe with a 1.8 liter engine. A little bit of history on this car. It has a rough idle symptom, misfire complaint. It's had plugs, coils, I think, replaced or at least moved around. They've done a mass airflow sensor and engine cleaning, basically in the oiling system, not a fuel injection type cleaning or anything like that. They ran a flush through the engine. This being a VVT or variable valve timing engine, they were concerned about that. And it's up here for us. So you can see trouble codes. We have our misfire trouble codes, and some of these we probably set in our testing already. When this car came in, it had a cylinder number 4 misfire code only, although they are claiming that we are getting multiple cylinder misfires, as you see up here. We want to ignore this mass airflow malfunction because they swapped out the mass airflow and that didn't fix it, so that would be a code set by this garage. But starting with our trouble codes, this is what we got, symptoms, and the next thing we're going to do is we're going to look at our fuel trim data. The reason we're going that direction is we don't feel a distinct cylinder specific misfire. It's pretty rough, and I want to look at the fuel trim data next. Okay, so I've pulled up the data on this car. I limited our data parameters to speed up the process, and there's 3 main ones I want to look at here. It is my upstream O2 sensor and my short-term and long-term fuel trim. Go ahead and start the car. This car's been sitting for a few minutes, so we gotta give this thing a chance to go into closed loop. We don't want to overanalyze these numbers just yet. As soon as this car goes into closed loop, we'll know it by the short-term correction. As soon as this short-term starts moving, we will know that this car dropped into closed loop. So far what I'm seeing is a lean O2 signal, but again, O2 is not hot yet. We just started the car, so we don't want to overanalyze that. Certainly don't like the long-term memory at 22%. You know, that's indicating a rich command, indicating a lean condition. Short-term just started correcting. You saw a 1, 2 on the short-term. So that computer is now in closed loop. If we were to graph this, you would see the up-down movement. Just hard to see on the Solus here, the graph, so I'm just leaving it in digital mode. One of the things that we want to do when we see lean conditions like this is we want to change our RPM, and I've mentioned this in a few of my other videos, and we have a section in my book on, I think it's section 5 on oxygen sensor testing, where we change our RPM and we look at what these fuel trim numbers do at higher RPMs. Do they get better? Do they get worse? And that gives us some direction. So we definitely have a lean condition, which we suspected from the symptoms and everything that was done to the car so far. I can see it for sure. And what I'm going to do now is raise the RPM. Let's see what these numbers look like. Let's do that again. So at idle right now, 700 RPM, definitely running lean. It has been corrected for though, right? Because our short term's in a decently normal range. The computer has corrected for it. Let's change our RPM again. See a 2 grand, still showing that lean condition. Looking at the long-term memory, the memory at 2500 is a little bit better. We're at 16. All right, that was kind of interesting. You saw around 3000 that long term was what, 9, and then short term was like negative 10, 12, somewhere in that range. and then it went a little bit higher, and you saw the long term go positive again. What we did yesterday is we did a smoke test on the intake for this, and the reason we went that direction was when we saw the fuel trim numbers getting better at a higher RPM, we suspected we had a vacuum leak. And what we found is that's not the case. There is no vacuum leak on this engine. I think one clue to that, if you watch this again, at one point it does show better, but then I go a little bit higher and it goes way positive again. So I'm going to show you that one more time. Watch it. And that's not a symptom of a vacuum leak. So definitely misleading there at first, but let's watch it again. So better right there. Go higher. See it like 3,500, that cell, its memory was positive 25%. So that's putting us away from a vacuum leak. We missed that yesterday. So we have a lean condition. It is confirmed. I'm not so much worried about ignition type misfire. I'm not worried about the misfire in itself, like compression or ignition. This stuff was already checked. We're worried about maybe fuel. So the next thing we're going to do is we're going to do an injector balance test and see the result of that. Okay, I kind of jumped the gun on you guys on that last segment. I said we're going to do a balance test. You know, we know where this problem is on this car. I'm going to show it to you, but there's some preliminary things you want to do for any lean condition, and one of them would be smoke test the intake, look for a vacuum leak. We've done that. There isn't one. It's no wonder these guys replaced this mass airflow sensor. They were trying to attempt to fix a lean condition. Common cause for a lean condition would be a dirty mass airflow. That did not fix the problem. And another one would be just checking your fuel pressure. So go ahead and start the car. Let's see what our fuel pressure is. Now, unfortunately, I don't know what the spec is offhand on this. But one of the things that I'm looking for when I do a fuel pressure check is I want to make sure pressure isn't dropping. And you see we have about 48 PSI, and we will double check that spec here in a minute. 48 PSI, but what we want to do is we want to snap it. We don't want to see any major pressure drops on a snap. It should hold pretty steady. Now this is a returnless system, so we're going to see a little bit of a drop, but we don't want to see much at all. It's going to be snap throttle. A little bit of gauge fluctuation's okay. One more time. So that's a good pressure in my eyes. That looks okay. And again, we'll compare that to spec, but I don't think fuel pressure is going to be our problem. We're going to move on to the injector balance test now. Okay, we just checked the spec for that, and for this vehicle, it's 44 to 50 PSI, and that was key on engine off number they were giving you. We were at 48 with the car running, so we're saying that fuel pressure is good. And again, we did a snap throttle test because what we were trying to do is open the injectors up real wide and make sure that that pump was able to keep up with those wider injector openings, and that's what we saw. So we're going to say our fuel pressure looks good on this vehicle. All right, so we're doing the injector balance test, and I'm going to use a timer tool. This is made by OTC. And we picked a center 50 pulse or 10 millisecond setting. And what we're going to do is we are going to fire each of these injectors for the exact same interval while we're watching the pressure drops. I've shown this in a few other videos. One was a 2005 Neon. That video quality was very poor as I shot that one with my phone, and it was the first one I did. But same procedure I did on that car. And the issue that I had in that car is my injector connectors were different. That's no big deal. I'm just going to adapt some T-pins and some jumper wires, and we're going to fire these injectors individually, one at a time, looking for our flow rate. Okay, what I'm going to do is I'm going to focus you guys in on the fuel pressure gauge so you can see the numbers. I'm going to use the scan tool in a bidirectional mode to command the fuel pump to turn on. That's going to allow me to bring my pressure up to the number I want and get up to rest pressure. If you didn't have a bidirectional control, you can certainly crank the engine over each time, or you can cycle the key and you can get the pump to run that way. Certainly easier to do when you have the ability with the scan tool. And what I'm going to do individually is move my jumper wires, which are attached to my tool, as you see right here, to each injector, starting with injector number 1. Okay, the important part about doing a balance test when we're relying on rest pressure is just that, it has to hold. If rest pressure is dropping, that means there's a problem with either a pump check valve or something leaking in the system that's going to interfere with what you're trying to do. So it's important that our pressure holds. You need to understand that the pump is not running when we're firing the injectors. We're just bringing rail pressure up to a number and it's going to hold. So I cycle the pump, pump is on, turn the pump off, and we want to pretty much use the same number each time. And you can see that that's about 44 psi right now. I'm going to go ahead and fire the first injector. And we'll be dropped down to about 33 psi on cylinder number 1. One other thing you have to consider doing balance testing is if the engine's very hot and we're dropping pressure like we are right now, we can actually have fuel that will end up boiling in the rail. If you remember from air conditioning class or from engine class, we learned about the effect of pressure on a liquid. And if you raise the pressure on a liquid, you raise its boiling point. And so what happens as you're doing these tests, you're lowering the pressure, so you're lowering the boiling point of the fuel. And if the fuel starts boiling in the rail, it's going to mess up your reading. So keep that in mind doing a balance test. You really don't want to do this on a hot engine. Our engine's a little bit warm right now, so we're hoping this doesn't interfere with our readings. But that's something to consider. One other thing too is you don't want to do this more than maybe once or twice per injector. In my last video where I showed the scan tool version of doing a balance test, the scan tool would only let you do it once. You had to run the engine and go back in and then it would let you do it again. So we don't want to hydrolock this engine. With this tool, I have the ability to fill this cylinder up entirely with gasoline, and then you crank the engine over, you snap a connecting rod. That would be a pretty bad thing. So you got to be careful about what you're doing. I'm okay with doing each one twice. 2 times is okay. So we'll do that. I'm going to pressurize it one more time. Pump's running. Shut the pump off. I want to start with my same rest pressure, so I'll give that a second. Let that drop just a little bit. And I'm okay with a slight drop. So we're about the same area we were. 44. Fire that injector. Looks like about 33. Okay, so now I'm going to the next cylinder. All right, I'm on the next cylinder. I'm going to run the pump again. Get my rest pressure to where cylinder number 1 was. This is cylinder number 2, or injector number 2. Go ahead and fire it. And it looks like about 34 psi. On injector number 2. So I'm going to do it again. .44 as the starting point. 34 as the ending point. So right there we have a 1 psi difference between cylinder 1 and cylinder 2. That doesn't sound bad. There's a number that's used, and it's one I actually have too in my book, is no more than 1.5 psi from lowest to highest. But I have to tell you that on good cars, they're all the same. And so I don't like this already. I don't like this already. That 1 psi difference, that might not be enough to give us an issue, but I'm seeing a flow rate difference between injector 1 and injector 2, and I don't like it. Especially on a car that is having an issue and a roughness and a misfire code, lean conditions that aren't going away. This is a concern. So moving on to cylinder 3, injector 3. Repressurize the rail. Very nice, so I can do it with the scanner. Shut the pump back off. Again, we want the same starting point. Hit the button. 34. One more time on injector 3. Okay, 34. Now I'm going to injector 4. And this is the one, when this car came to us, all the misfire codes were cleared, but cylinder number 4 was the first one that came back. So when we first got this car yesterday, cylinder 4 was the first one to come back. This is the one that we were really focused on because of that. So we're doing number 4 cylinder now, number 4 injector. And we are at 37. So cylinder 1 had 33, dropped down to 33. Cylinders 2 and cylinders 3 dropped down to 34. So what we know right away is number 1 is flowing the most fuel. 2 and 3 are behind that, 1 PSI difference. Nothing to really raise a red flag about, at least as far as specs go. But when you do enough of these, you'll find that on good cars, they are identical across the board. And then what we see on the number 4 cylinder is this only dropped to 37. So that's a 4 PSI difference from lowest to highest. That is a problem. This is our lean condition. This is what's causing it, is we have injector flow issues on this engine. It primarily the number 4 being the worst one. So I'll do it one more time. Let's look at it again. Definitely an issue, no question about it. This needs to be handled. I believe this will take care of our lean condition, this will take care of our roughness complaint, and this will take care of our misfire trouble codes. What I want to do is show you guys now how to do a fuel injection service. There's multiple ways to do this, but we're going to do that. We're going to clean these, see if we get a result. Cleaning them, if it doesn't work, then we're going to have to replace these injectors. And I would recommend all 4 from what I'm seeing. I don't like the flow rates, even the difference between 1, 2, and 3 I don't like. I'm going to suggest doing all 4, but we're going to try to clean them first, and maybe if possible we can try some pressure transducer testing and see if we can identify this injector problem using a electronic pressure transducer. I'm not sure how that's going to turn out, but maybe we'll include that too. But next step is going to be, for sure, clean the injectors and then redo this balance test and see if we took care of this flow problem. Okay, I did decide that I want to show you guys this pressure transducer test. So the tool I have connected here is a Fluke PV350, and I'm using a pressure transducer. That's what it is. I'm attached to my fuel rail, basically the same place my gauge was at. I just connected this pressure transducer, and I'm going to use the Picoscope, and we're going to look at these pressure readings on the computer. Okay, so you can see the tool setup. It's the PV350, my pressure transducer. I'm adapted to channel A using my Picoscope 4000 series, and we're going to take you up to the board now, and we'll see what these pressure readings look like. Theory behind this is we should be able to identify a injector that has a different flow rate by monitoring rail pressure with a pressure transducer. So that's the theory behind this, and this is the first time I've done it, so hopefully we'll be able to see what we're looking for. I think it's a valuable tool to learn because there's going to be times where you have intake manifolds that are going to cover the injectors and you can't get to them, but maybe you can get to the rail and do a pressure test. So I think it'll be a very valuable test. I want to say though too that I don't have any known good ones to go by, so it might be useful in this video too to put in a known good one and see what it looks like. I'm not sure if we'll have time to do that, but certainly that needs to be done. To be able to pick out a bad one, you need to have seen, I think, multiple good ones. So we'll see what it looks like. Okay, our settings for this scope, I'm on a 100 millivolt screen. The reason I'm on a 100 millivolt screen is every 1 millivolt is 1 pound of pressure using this PV350 on a PSI scale. So 1 millivolt is 1 PSI. If we did this right, we're gonna have around 45 PSI when we start the car. Go ahead and start it. And you see that's what we have. We got 46.3 millivolts on the screen. I think that's pretty accurate for what we were doing. I don't remember exactly where we were on the pressure gauge. You guys remember? Or was it? Was it 47, 48? All right, so that's pretty good. I like that. So we are reading our fuel pressure electronically now. And the nice thing about using the Pico is there's a couple ways that you can do this. You could AC couple it, and what that's going to do is block out all of the DC constant, and then we could lower our millivolt scale and really zoom into that. I don't need to do that because of the zoom feature that's on this scope. I can just take this and zoom in on a section of that and really see the detail behind that. Now there's a couple things that we're looking at here. What you have to remember is fuel pumps, as they're spinning, they have impellers, and you're going to see pressure impulses from a fuel pump. And what we want to try to do is coordinate the pressure impulses from the pump away from the momentary pressure losses of the fuel injectors. And so I think what I want to do to emphasize that is I want to put in a second channel, and we're going to synchronize with the number 4 injector, which is our flow issue, and let's see if we can pull this out in the picture. Alright, so this second channel, I'm going to be looking at a fuel injector which spikes over 100 volts on some of these. We need to be careful about the input of the Pico. We don't want to exceed its limit, which is 100 volts on the 4000 series. So I'm going to use a step down, what's called an attenuator. And this steps the voltage down by 20, so I can look at much higher voltage levels. I just needed to tell my scope what I'm doing. So I'm going to look at the control wire voltage on the number 4 injector. Let me get this set up. I'll show you the setups on the screen. So channel B is the one I'm going to use. We got a battery ground for my black lead, and for my red lead, which is my positive for channel 2, I'm going to the injector control wire. Turn this on, and I'm going to tell the scope what I'm doing, which is I'm using a 20-to-1 attenuator. And our injector waveform is way down here because we're zoomed in very high on this scale. So there's a couple different ways to do this. Let me just pull this up into the screen so you can see it. You see our voltage spikes on this are 123 volts. So it's a good thing we put this attenuator in. But we're not worried about the top of the spike. We really want to see where this injector is taking place, where that firing event's taking place. We can filter this, make it look a little cleaner. And now we can see repetition with this injector. In fact, a better way to do this now too is going to be to trigger off channel B. And what that's going to do is keep that stationary on the screen. And now we can see that number 4 injector firing multiple times. Now we're not worried too much about the detail of the fuel injector. We're not looking at pintle hump and all that stuff. We just want to see where this injector is firing in relation to the rest of them. And this part's a little bit difficult to pick out, but let's put a cursor in here and let's talk about this for a second. Now what we're looking at here would be pressure drops. As the injector is turned on right here, this is your on time or your pulse width, we're going to have a momentary pressure drop in that fuel rail. And of course it's going to be delayed. It has to build the magnetic field, the pintle is going to open behind that. And then when the magnetic field collapses, the pintle is going to be, again, lagging behind the electronic part. So it would make sense that our drop in pressure would be just after that event. And so what we're looking at is this drop right here is going to be a representation of my number 4 injector flow. And then we would go in firing order sequence from there. And there's my number 4 again. Now, I don't know the firing order offhand. It would probably help to have that right now. pause that. I'm going to look up the firing order. Here's our firing order, 11342. So we'll go back to our scope. And now looking at this, we know that this is cylinder 4. So this is 1, right? And this is 3, 4. Did we do that right? Sorry. What's our firing order? 1, 3, 4, 2. So this is number 4 is the one we're triggered off of. That's going to make this the number 2 right here. And this is going to be the number 1. And this is going to be the number 3. And then back to number 4 again. Okay? Do you guys remember when we did our balance test? Which one had the best flow rate? Which one had the most flow? Number 1 cylinder had the most flow. Can we see that up here? Yes, we can. And we can also see which one has the least amount of flow, which is going to be, in our case, the least amount of pressure drop. And that is clearly the number 4 cylinder. Okay? I think it's important to note here that there are some other oscillations in here, and you have to remember that the fuel pump is going to create those pressure impulses too, and that can make this a little bit difficult. I think maybe what I'll do here is I'll unpause this and I'll unplug another injector, and we'll see what that looks like on the screen and see if we can see it in more detail. I think it's pretty clear though, just looking at this, that number 4 cylinder certainly has the least amount of flow. But man, if you didn't see enough good ones, it would be pretty difficult to use this test by itself and not have known going into it that we had an injector balance problem. But I'm going to unplug one of the other injectors. Let's see what this looks like. This is going to be number 3. We'll unplug the number 3. So number 3 is unplugged right now. Pick a different one. There's number 2. You can certainly see it. You know, I see a 1 here, 1 here. We can kind of see our number 4. Number 2's missing. Is that right in the firing order? Does that match our firing order? So you see number 2's missing. But you still see the impulses of the pump. So I think the hard part about using this, again, is that we have those impulses from the fuel pump combined with the pressure losses of the fuel injectors, and it makes this test a little bit difficult. And you can see the changes here, like that was even deeper now with the number 2 unplugged. So there's some changes that, you know, you have to be careful using this. And you know, why is that one showing a higher pressure loss with the number 2 out of the picture? I'm not really sure I can explain that. At least not at this point. There's the number 3 unplugged. So you see our cylinder 4, this is 2. What's the next one? 1, 3. Cylinder 3, no pressure drop. So can we use this test to identify a no fuel spray from one fuel injector? I think yes. Can we use this test to pick out an injector that's maybe 1 PSI different from the other one? I'm not sure. Can we see 4 PSI difference like we have? Yeah, we can see it. Let's plug it back in one more time. This is all 4 again. We could look at that in maybe a little bit more zoom if we wanted to. Really pick out those pressure drops for each injector, and I'm going to line this up to our number 1 or our number 4. Certainly this shows you more than a balance test would, because we're seeing repetition with a fuel injector over and over again, where the balance test is only giving you really one event. I like that picture. I think I'm going to start using more of this, and we'll get some known goods. I'm not going to do a known good for this video. I think it would make it too long. I think that's clear enough right there in what we're looking at as to an injector problem. Go ahead and shut that off. I have this paused. I think that's a pretty good capture. I think from this point what we're going to do again is we're going to clean it, and we'll see the result afterward.